Welcome to this new tutorial on multi-chain mobile gaming with Quicknode. Today, we are going to receive data from both Solana and EVM compatible networks to display a game ranking on screen. We will also adapt our previous tutorial code to host a falling boxes minigame made using Flutter Flame. Let's clone the repository called DINOGROW pre-ranking with the falling boxes game ready, along with all the functionality from our previous tutorials of this series. The link is in the description. Create a .env file in the root and create these three variables. We need to go to quicknode.com and create endpoints for Polygon Mumbai, Binance Testnet, and Solana DevNet, and place them in each variable accordingly. Let's also create these three new variables to store the contract addresses for Polygon, BSC, and Solana. We will modify the Solidity contract from our previous tutorial, adding these variable users as a list of addresses. In the SaveScore function, we will now map the structs of type user score to the user address received in the function, and we will add any new user received to the users list if it hasn't been added before, so we check if the users are already stored in the list. And we create the getScores function, which will create a new list of integers, each with the corresponding score for each user in the allusers list, and returns both lists. Let's compile our new code with the 0.8.9 compiler selected and copy the new ABI and replace the old one in the ABI.json located in the assets folder. Let's deploy our contract using injected provider with our MetaMask setup for the BSC chain. Copy the address of the new deployed contract and paste it in the appropriate field of the .env file. Let's repeat the process, this time with our MetaMask setup for the Polygon network. Copy the deployed Polygon contract and paste it in the env file. Our Solana program will go without modifications, so we can just paste the declare ID and we are ready to go. We have changed the random root in our new repo to return this game widget falling boxes that you can check out in the pages folder fallingboxes.dart file. Here lies the code of our Dino minigame. There's also a new Flame folder with some other necessary components used in our game. And the assets folder now has this image folder with all of the images used in the game, like background elements and sprites. Feel free to experiment with this file to give your game your unique touch. In the pubspec file now, we have imported the Flame and Flameforge 2D files. If you run the app, you'll see that our play button now takes us to our minigame. The goal is to avoid the falling boxes and get the maximum score possible. This score is now the number we'll be sending to the blockchain. To do this, we're simply going to use the SaveScore function we created in our last tutorial. So, in the fallingboxes.dart file, search for the showEndMessage function and in the onPressed parameter of the button at the button. Let's load the connect data and display data variables, importing the necessary libraries. Then we call the SaveScore function, also importing the respective library. This function will receive the connect data parameter and the score achieved during the game available in the score variable. We'll call the display result function with the result and the display data. This function we can copy from our random.dart file created in the last tutorial. In this case, adding the display data variable as a parameter. We can now run our app, connect to any blockchain, and hit to play the game. When the game is over, we can now send the achieved score. With the Send Score text button in the alert dialog, and we'll see the result of the transaction with the logo of the chain we are connected to. It's time to fetch the data from the different blockchains. For this, let's create a file getscores.dart in the services folder. Let's also create a file score.dart in the models folder, with this score class containing the strings, score, and address. Back in our getscores file, let's import these libraries and create a function getscores that will return a future of type score. This function will receive the connect data. Our function will initialize a list of type score, and for the EVM blockchains, we'll first read the contract address from the appropriate variable in the .env file and create an Ethereum address type variable with this address and call a getScoresEVM function, which we'll create now. For the Solana case, it will call a getScoresSolana function. The getScoresEVM function receives the RPC, the contract address, and the EVM credentials. We load the ABI from the assets folder, create a contract instance with this ABI and the name of our contract user scores. Now we define the function of the contract we are going to access. This will be the getScores function. Create the EVM client like we've done several times. And now we'll use the method call available for our client with the contract instance, the function, and an empty list of parameters, since our function doesn't require any. If the obtained result is not empty, we should receive two lists of type dynamic, the first one being the addresses and the second being the scores. We can see this in the Solidity contract where our function returns these two lists in that specific order. So here we'll map each item of both lists converted to string to a new list and save the result in the variables addresses and scores respectively. Then we'll generate a list of type score using the generate method of the list class and returning a score instance with the elements of our addresses and scores lists in each iteration. This way we'll have all the scores stored in the contract with the respective user address in a score type list, which our function then returns. Now let's create our function getScores Solana, which will receive the Solana Quicknode RPC and will also return a future of type list score. We'll define an empty list of type score. Create our Solana client like we've done many times. Now let's get our Solana program address from the .env file. Now we are going to get all the PDAs associated with our program. This is how we get all the scores stored in the blockchain. We do that using the getProgramAccounts method, available in our client with the program address and the parameter base64 for encoding. This function will return a list of accounts, each one returning serialized data, which we'll have to deserialize. We first iterate through the resulting list and get the account.data parameter for each account as binary account data and save it to this bytes variable. This will be our serialized data. Let's now create a Borsch serializable class. Go to the anchor types folder and create a getScores anchor.dart file and make it look exactly like this. We need to put this deterministic ID U64 parameter as our very first parameter because this is a standard ID number that the blockchain sends inside the serialized data. Then we define our two variables coming from the program in the same order they are saved in the string user score. That is the U32 type score variable and the public type address variable, which is called user in the program. Let's run Flutter pub run build runner build to generate the second part of our Borsch serializable class. And back in our getScores file, we can import the newly created getScores anchor class and use the from Borsch method with the data parameters in our bytes variable to have our deserialized data in this decoded data variable. Now we are going to create a score type variable item and save in its address and score parameters the address and score data that has just been deserialized for each of the accounts received, both converted to string. Now we add each item created to the score list, which will return after iterating through all the accounts. Our get scores function is ready. Let's now create the page to display the ranking of our game. In the pages folder, create a ranking.dart file, and inside it, create a stateful widget ranking page. Create this empty list of type score, which must be imported, a flag to handle the loading state, and our variables connect data and display data, importing the necessary libraries. We'll call a getData function in the init state. This function will get the display and connect data using the respective functions, for which we must import the libraries. Call a getRanking function. Here, we are going to fetch the data from the connected blockchain using the getScore function we just created, passing the connectData variable. Our widget will consist of a scaffold with a button to go back to the home route. This container in the body hosting a column. On the top, we'll place the logo of the chain we are connected to, the title top scores. Then this container wrapped in an expanded widget, and inside it, if the data is still loading, a progress bar, and when we get the data, this refresh indicator widget with a list view builder, which will sort the items and display for each score instance in our items list, a list tile with the position in the ranking, the address of the user, and the score of the user. Before testing this out, you can go to your deployed contracts in Remix and use the SaveScore function to populate the contracts with some data using different scores and addresses. Remember to have your MetaMask set up to work in the same chain that the contract you're accessing is deployed to. We do the same process for Polygon, sending some test data. Now, to do this on Solana, use the Test tab in SolPG. Access the SaveScore function. Input any score and generate a random public key for the user. In the Accounts tab, you must derive the score using from seed, the string random, and the address of the account that's connected to SolPG and thus is signing the transaction. This is the way we set up the contract. In Player, you must also use this address. We can now run our app and check the ranking created with the data we have written to the different blockchains. Our multi-chain game is now writing and reading data from the different blockchains. We hope this video is helping you build your own Web3 game. Subscribe, like, comment, and share. See you next time!